What we're going to learn in this video is how to convert quadratic equations from standard to vertex form. So title a new page in your spiral notebook, and just remember that as we go through this video, okay, to utilize the pause key when needed so that you can stop and make sure you have time to write things down so that you can listen to how to do the problems, okay? So when you're ready here, let's review what these two forms look like before we get into our first example. So standard form looks like this, okay? Often when we solve an equation by factoring or when we do the quadratic equation, our first step is to write the equation in standard form and we set the equation equal to 0. So standard form is really good for solving. Well, vertex form is the one that looks like this, okay? It looks like this quantity x minus h squared plus k. And vertex form is good for graphing, mostly because the vertex is in the equation. So if you remember, the vertex is going to be the h value and the k value. And so it's going to be the vertex is hk. Remember that this number will be the opposite of what it looks like in the equation. And so what our goal for today is to go from standard form to vertex form using a skill that we have learned called completing the square. All right, so let's start with example 1. And what we're going to start out by doing is we are going to write this function f of x equals x squared minus 6x plus 5 in vertex form. And then we'll use that vertex form to review different parts of the graph. So first thing we're going to do is we're going to set up this problem, okay? And I like the x's a little bit better over here on the left. So I just kind of make my first step. I kind of turn the equation around and I flip-flop it and I put the variables over here on the left. And so what we're going to do is use completing the square. And so our first step of completing the square is to write the constant term on the other side of the equation. So write the constant on the other side. Okay, so using whatever opposite operation we need to do. So in this case, we're going to minus the 5 over to the other side, and it's going to look like f of x with the minus 5 over there on the right. So the next thing that we're going to do is we're going to do what's called complete the square. And this is how we are going to get this quantity squared right here when you look at vertex form, okay? This part right here with the parentheses squared, you do that by completing the square. And so when we complete the square, what we're going to do is we're going to turn this left side right here into a perfect square trinomial. We're going to add that perfect square that will make it factor special. And you're allowed to do that as long as whatever you do to the left side, you add that same thing to the right side. And so if we can remember what was the little formula we did to figure out what that perfect square needs to be that goes in the blank. Well, we take half the middle term, so half of -6 is -3, and we square it. So whether we're squaring a +3 or a -3, it's always going to make a positive, which is why we always put plus blank on both sides. And so just a little reminder, we take half that middle term and we square it. Now, the point of doing that is to factor the trinomial. Factor the trinomial. And this factor's special, okay? Once you make it a perfect square trinomial, it will always factor to be x plus or minus depending on the middle term. And this number in the factor is always half the middle term. There's a pattern, and that's what we talked about before we started completing the square. And so when we factor x squared minus 6x plus 9, we're going to get x minus, and then half the middle term is 3. Okay, and we're going to write that as x minus 3 squared. Because really what we're doing when you factor this is it's going to factor to make x minus 3 and x minus 3. So we're going to just represent that as x minus 3 squared. Okay, now over here we have this f of x, but then it's -5 plus 9, which is going to combine to make a 4. So let's go ahead now and get the constant back over on the same side, And so it's x minus 3 squared minus 4 equals f of x. So finally, this last step is going to be to write the equation in vertex form, which we basically just did, but now I'm going to kind of flip this around and I'm going to represent this as x minus 3 squared minus 4. And so that is how we get this equation into vertex form. It's that completing the square piece that creates the quantity squared. All right, so the next thing that we're going to do is we're going to graph this equation. All right, and we're going to remember, first off, how to get the vertex. Well, the vertex is going to be, the h value is right here, and the k value is right there. So the h value is going to be positive 3, and then the k value, or the y coordinate of the vertex, is negative 4. So just remember that this part does the opposite. This x minus 3 means it moves right 3, and the negative 4 means that the vertex is shifted down 4. Therefore, the vertex is a positive 3 and a negative 4. So let's go ahead and set up the graph of this on a coordinate plane. You are probably just on notebook paper, so just do the best you can. You can just kind of freehand this. You'll get a chance to do this on graph paper in class. All right, so the vertex is at negative 3, negative 4. The other thing we need to do before we graph this is we need to review how to graph a regular parabola with a vertical stretch of 1, since this parabola has a normal vertical stretch of 1. And remember how this pattern goes is you start at the vertex and you move over 1 and you go up 1 squared, which is 1. And then you move over 2 units from the vertex and you go up 2 squared, which is 4. And if we went over 3, we would go up 9. And you recall that pattern, right? So all those vertical heights are all perfect squares. So the way we're going to graph this is we're going to move over 1 unit from the vertex and we're going to go up 1. And then we can reflect that across the axis of symmetry. And the axis of symmetry, again, is this line that goes right smack dab through the middle. Now when we go to graph another point, we can move over 2 units from the vertex and go up 4 units. All right, and we'll look at our next example about how to graph different vertical stretches, but that is how you graph a basic regular parabola with a vertical stretch of 1. So let's reflect this point over, and really pretty easily we can graph this parabola with 5 points of accuracy, and it doesn't take too much time at all. All right, so the next thing I want to do is review some different parts of the graph so that you're ready to do our activity that we're going to do in class. So we're going to review here how you state the domain of a parabola, the range, the decreasing interval, the increasing interval, and then we're going to talk about the type of roots that we see. All right, so let's just kind of take a minute and set up some blanks here for these different answers. Now, the domain of a parabola is always going to be from negative infinity to infinity, right? Because at the vertex, the parabola goes forever to the right, and it goes forever to the left. And so what we call this for the domain is negative infinity to infinity, okay? So unless the parabola has endpoints, it's always going to be negative infinity to infinity. Now the range of the parabola is going to be the vertical span of the graph, and it's going to go from this lowest point, which is at negative 4, and we can see that the parabola goes up forever, and so the range is going to go from bracket negative 4 to infinity. And we use a bracket because that negative 4 is included. Now let's talk about increasing and decreasing, okay? Again, what we do is we look at our domain, and the domain splits in half at the axis of symmetry at 3. And so when we talk about increasing, decreasing, we're talking about how the parabola over here on the left side, okay, if you kind of follow along, what's the parabola doing? And it is decreasing. So over here on the left side of the vertex, we would say the parabola decreases. Then it hits its lowest point and the parabola starts increasing. And so on the right side of the vertex, we would say that the parabola increases. So the decreasing interval is going to be from negative infinity to exactly 3. So from negative infinity to 3. But then the increasing interval is going to begin at 3 and go to infinity. And so just kind of remembering when we do that increasing, decreasing, we use the axis of symmetry to divide that parabola into a left half and a right half. And then finally with the roots, okay, we can see the roots right here, and the roots are the x-intercepts. And what I'm going to ask you for the activity in the class, okay, is whether the roots are real or imaginary. And since the roots are on the x-axis, they would be real roots, okay? And we can also see that the roots are going to be positive 1, 2, 3, 4, and positive 5, okay? But what I'm going to ask you is whether those roots are real or imaginary just by looking at the graph. All right, let's take a look at another example of how to convert from standard to vertex form. So, example 2. Let's use y equals this time just to kind of change up our notation. 3x squared plus 12x plus 16 in vertex form. And then again, we're going to graph the parabola as a little review. All right, so step 1, again, is the setup. And so what I like to do is I'm going to kind of switch this equation around so that I've got my x's over here on the left, and I'm going to put the equals y on the right. And then what we're going to do is we're going to get that constant to the other side. So this is going to be 3x squared plus 12x, and we're going to minus the 16 to the other side. Okay, so we're going to get that constant on the other side. And I don't think it's a bad idea for you to write out the steps again, because I think seeing the math and writing the steps in words is going to help it stick in your brain. So what we're going to do now is, we didn't have to worry about this before because we didn't have an a value. Well, we had an a value, but before in example 1, the a value was 1. So we didn't have to worry about this step, okay? But if you do have an a value other than 1, we're going to need to factor out the a. And so what I mean by that is we need to divide the 3 and put it out in front of the parenthesis. And so when we divide both of these terms by 3, I'm going to get x squared, and then 12x divided by 3 is 4x. And so let's just take a look really quick at what we did. What we basically did is we undistributed the 3. So if I were to distribute the 3 back in, I would get back to the step above. So I'm not changing the equation, I'm just changing the way that it looks. And that is how you get the a value out front in vertex form. So now what we need to do is complete the square. And in this step, when we complete the square, we're going to set this up by taking the x squared in the x term and adding that perfect square, right? So we're going to put plus blank. And we can do that as long as over here we add the blank. Now here's the catch. It's really going to be 3 times 4, okay? So over here we need to write 3 times the blank. And that's probably the biggest thing with this a value, is just making sure that if we have times 3 over here, that we balance it out with a times 3 over here. So again, how do we get that middle term? We are going to take half the middle term and you're going to square it. So half of 4 is 2, and when we square that, we're going to add 4 to both sides. All right. So now what the point is we need to factor the trinomial. And in this case, it's going to look like this. We're going to have our a value out front, and it's always going to factor to be half that middle term, okay, with that a value out front. And it could be plus or minus depending on the middle term. So this, we're going to bring the 3 down and leave it out front, and x squared plus 4x plus 4 is going to factor into x plus half the middle term is 2, and that would be quantity squared. So again, what we're really doing is factoring it into x plus 2 and x plus 2, but the point of completing the square is to write that as quantity x plus 2 squared. Over here we have y minus, well, I don't know if it's a minus. Let's do this. It's going to be y, and then we're taking a negative 16 plus 12, and it's going to make a negative 4. So let's write this in vertex form now, and let's add the 4 back over. And what we get is 3x plus 2 squared. And I'm just going to flip this around and write this equation in vertex form. And it's going to look like y equals 3 times x plus 2 squared plus 4. Okay? So let's go ahead and set up the graph for this and identify what our vertex is going to be. Okay, well, in this case, the vertex is going to be the opposite of this number. Okay, so the vertex is going to be the opposite of this, comma this. And so again, in words, remember this means that the parabola shifted left 2, and this means the parabola shifted left 4. So the vertex is going to be negative 2, comma 4. Negative 2, 1, 2, 3, 4. You know what? I can already tell that I'm going to need a little bit more space. So I'm going to do this. I'm going to, I don't know if I have quite enough room here, but we'll make the best we can. All right, we'll put this right down here at the bottom. Okay, so negative 2, 1, 2, 3, 4. And so let's remember how we're going to graph our y equals x squared parabola. Well, what you do, and this is what you need to have memorized, you go over 1, you go up 1. You go over 2 units from the vertex, you go up 4. Well, if there is a vertical stretch of 3, then that means that all these vertical quantities are going to be multiplied by 3. And so when we graph this, we're going to go over 1, but we're going to go up 3 units, which is going to make that parabola more narrow. And then we're going to move over 2 units from the vertex and go up 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, this is really pretty high. It's just, I think, because on this grid that I have, these boxes are really wide, but you'll be able to get this to fit on the grid that you do in class, okay? Not the prettiest parabola I've ever made, but you get the point right there, okay? So that's what we're going to work on in class, is we're going to work out how to use completing the square to convert. We're going to graph the parabola in vertex form, and then we're going to review some different attributes of the parabola. The last thing I'm going to say to wrap this up, okay, is since the parabola does not cross the x-axis, we would therefore know that this parabola is going to have imaginary roots, which is what we've been practicing in class finding. Okay? Well, hopefully this made a little bit of sense, and we will work on